You have now seen what an equation looks like in point-slope form. Y minus y1 equals m times the quantity x minus x1. You only substitute values for y1, m, and x1. All else remains the way it is. Here's an example. If you are told that the slope is -7 and 4, 2 lies on the line, well, you know that this 4 is your x-coordinate and the 2 is your y-coordinate. So let's use the equation to write it in point-slope form. Y minus 2, because that's y1, equals my slope m is -7 times the quantity x minus x1, which is 4. And I'm done. There is my equation written in point-slope form. Let's try another one. I'm told that the slope is 5/2 and that -3, 0 lies on the line. Why don't you pause the video here and try to write this in point-slope form? The answer is y minus 0 equals 5/2, which is my slope, times the quantity x minus -3. And look what happens there. We can simply say y minus 0 equals 5/2 times the quantity x plus 3, because two negatives make a positive. Try one more. Your answer should be y minus 1 equals 2/3 times the quantity x plus 4, because again, two negatives turn into the positive. Now, the good thing is that I can use point-slope form to help me graph. Here's what I mean. I know here that the slope has to be 3 because m is right outside the parentheses. If I wanted to write this as rise over run, I could put a 1 under it. The coordinate, well, x minus x1, so that means x must be 1, and y minus y1, so y minus y1 is also 1. Now to graph this, that means I can start at the point 1, 1, there it is, my coordinate, and from this I can go 3 up because that's my rise, my slope, and 1 over, my run, and follow the pattern. Rise, 3, run, 1, and then you can make a line connecting your points. Why don't you try this one? Pause the video here before checking your answer. So I know, once again, that the slope m, right outside the parentheses, in this case, is -1 over 2. That means I go down 1 to the right 2. My coordinate, x minus x1, so that's 3. Y minus y1, but that says y plus 2. Well, how did this minus change into a positive? It must have been y minus -2. So I know that y1 must be -2. So to plot this, I'm going to start at the point 3, -2, and go down 1 to the right 2, down 1 to the right 2, and I'll go one more time down 1 to the right 2, and then I can draw a line to show what this equation looks like. If you would like to try this one, you can get some help, and the answer here, if you would like to check it, would be the slope is 2/3, your coordinate is 1, 3. So start at 1, 3, go up 2, to the right 3. And finally, you learned how to take the slope and a point on the line to write it in slope-intercept form by solving for b by substituting x and y. Well, here's an easier way, by using point-slope form. So I know that I can write y minus -2, so that'll be y plus 2, equals my slope -4 times the quantity x minus x1, x minus -1 would become plus 1. Now if I had to change this into slope-intercept form, that means I need y equals mx plus b. So I need to get y by itself. But I can't move things away till I always distribute first. So y plus 2 equals -4x minus 4. And finally, I can move everything away from y, subtract 2 on both sides, and I get y equals -4x minus 6.